Alright, let's look at a wire. It's pretty straightforward. It's sort of a cylindrical object. It has a length or a height we'll call h, radius called r. It certainly has an area cross-section called pi r squared h, and a circumference of 2 pi r. And we know that the current is flowing along the wire in the direction there, and the E field is also along the wire. And there's a B field which is circling around the wire. And we know that B equals mu naught I over 2 pi r at any radius, particularly at the edge of the wire. That's where we're interested in, because that's the centroid of the B field. It's located there, half in and half out. Okay, well, B is mu I over 2 pi r. And we can look here at our chart and see that Z equals B times B path, or Z over B path equals B. And we also see that Z equals mu naught I. So this here says B equals Z over some distance, which must be B path. So that's pretty straightforward. So our B path is 2 pi r. We'll put that right here on our chart. 2 pi r. And the E field, we know, runs the entire length of the wire. So our E path must be h. And then this one up here is labeled E area over E path. And the area is pi r squared. And the E path we already saw was h. So now we have labeled all of our lines. We can repeat the pattern on down here. This is pi r squared over h. And this is h. And this is 2 pi r. You can continue on down. You can also go up here. This one again will be 2 pi r, B path. Any three lines that you cross is talking about the same volume. Again, I'll repeat, that's not necessarily a physical geometric volume, but it is something which has units of volume. And that's what we're counting on being the same across the entire table. Next, we can start here with B equals mu I over 2 pi r. Use a small pen so you can see what I'm writing. B equals mu naught I 1 over 2 pi r. And if we now multiply by our distance here, this is simply mu naught I. 2 pi r's cancel. This one will be mu naught I h, and this one mu naught I pi r squared. The h's cancel. We go one more up here. We get mu naught I 2 pi r squared, and that's the volume we're talking about. 2 pi r squared. It's B path and E area. Okay, we can continue on down here. We get mu naught I pi r squared over 2 pi r h. Recognize that as cross-section over surface area, which is a very interesting geometric thing. we can come down here and we see that this is per volume. So mu naught I 1 over 2 pi r 1 over pi r squared. And this is the same volume we had up there, except now it's in the denominator because this is talking about a volumetric element, whereas this was talking about a volume of those elements. Here, now we get mu naught I 1 over 2 pi r squared 1 over pi r squared